Video we're going to do some more with conics. We're going to move on to ellipses today, and we're going to talk about kind of how to graph an ellipse. But there's some important vocabulary we need to know about parts of an ellipse. So the definition of an ellipse is a set of all points such that the sum of the distances from two fixed points, called the foci, is constant. And I'm actually going to play through here. I know this is a little weird video on video, but I think that this video really illustrates what a focus is. So F1 and F2 are the two foci. And so basically, if they stuck a pin in it and tie a string, and then they're going to use a pen and they're going to create an ellipse. So you'll notice that string is going to stay tight. So that is actually the definition of an ellipse. So that's kind of a nice visual there. Okay, so basically, so the distance here plus the distance here is always going to be equal to this distance plus this distance, is what that is saying. And those 2 points where that happens at are called the foci. Foci is plural for focus, okay? All right, so the other pieces that we need to know, so we kind of have like these 2 axes. So we have a long one and a short one. The major one, use the same color, the long one is called the major axis. Okay, and then each point here is called a vertex of the ellipse. So we have 2 of them. They are the same distance away from the center. Let me label the center here too. Use a different color. So my center. Okay, and then we have the short axis, which we call this the minor axis. And these 2 points are the same distance from the center. This is a co-vertex. So the 2 vertices are on the major, the co-vertices are on the minor. Okay, so another piece that we're going to look at here is the standard form of an equation of an ellipse. So an ellipse in standard form will always be equal to 1. It looks kind of like a circle. But we have this a squared and b squared underneath. So a and b, they relate to the major and minor axes. Okay, and I'm actually going to show this part down here a little bit first. Okay, so the major axis is still this. So the distance from the center to the vertex, that's a. So A is always whichever way the major axis is going. So if it's longer vertically, the A squared will be under the Y. If it's longer horizontally, the A squared will be under the X. Okay, and then the minor axis, so this length right here, from the center to the co-vertex is what we call B. So the B squared is in the equation, comes from there. Now, the focus is actually the distance from the center to the focus, which we're going to use C for that. So C is the distance from the center to the focus, and that's the relationship. It kind of looks like Pythagorean theorem a little bit, but C squared is equal to A squared minus B squared, and so what I get there for C is the distance from the center to the focus. Okay, so let's go ahead and try graphing one here. Okay, so these are things that I always want to include on my graph, and I want to label where they're at. Okay, so the center I get just like I do from the circle. It's opposite sign. The coordinate with x is the x coordinate of the center. The coordinate with y is the y coordinate of the center. There's no numbers up here, so my center is at 0, 0. Okay, then I need to decide what are A and B. So remember, A is always bigger. So this is A squared, and this is B squared. So what that means is it's going to be longer vertically because A is underneath Y. The bigger one's underneath Y, so it's going to be longer vertically. Okay, so A is equal to 7, right? A squared. And B is equal to 4. Okay, so what that means is when I graph my center at 0, 0, if I know it's oriented vertically, I'm going to go up from here, 7, and down from here, 7. So those are my vertices, okay? So we have 0, 7, and 0, negative 7 are my two vertices. Okay, co-vertices I get by using B. So I'm going to go out this direction, 4 and 4. So my co-vertices are at 4, 0 and negative 4, 0. Okay, so foci I need to get by finding C. So remember, C is the distance from the center to the foci. So we're going to use that formula. C squared equals A squared minus B squared. So 7 squared minus 4 squared. So C squared equals 49 minus 16, which is 33. C is equal to the square root of 33. Okay, that's not a nice perfect square. We're actually going to leave it like that, you guys. And here's how we write the foci. So the focus is always on the major axes. Okay, I'm actually going to add that. I'm actually going to add that on the other notes here. Foci always on major axis. Okay, so that means this is my major axis. So the foci are C away here. So it's my x coordinate is still going to be 0. And I'm going to go up square root of 33 and down square root of 33. So here's how I'm going to write that. I have 0 and then 0 plus or minus square root of 33. So there's two different foci here, okay? And they're going to be somewhere in here. If you want to graph them, you don't have to graph the foci, you guys, because usually it's not a nice value. But if we were to estimate square root of 33, 5.7, my foci is like right in here, right in there. You don't have to graph those, okay? And then we're just going to connect our ellipse. And you guys, you don't have to add labels to your graph. Sorry, mine looks kind of more like a diamond, but you don't have to add labels over here if they are clearly labeled here, if you want to add them, but putting those points where they're really easy to see is going to be good. Domain, so left to right, my x values go from negative 4 to 4. In this case, my co-vertices. And my vertices go from negative 7 to 7 for the y values. All right. Okay, let's try a different one. Okay, so this one, it's an ellipse. It looks like our standard form. It's equal to 1. Okay, so here, the bigger one this time is under the x. So that is our a squared, which means it's going to be longer horizontally. Okay, and then here is my b squared. So that means a is equal to 3 and b is equal to 2. Okay, so center, remember, just like a circle, my center coordinates are negative 2. That's my x coordinate opposite, and y coordinate is 1. Okay, so let's go ahead and put some things on the graph. All right, so we have negative 2, 1. This time it's oriented horizontally, so I'm going to go out 3. So from here, 1, 2, 3. Oh, I went too far. 1, 2, 3, sorry. Of course I used a pen. Cross that one out. Okay, and then I go over here, 1, 2, 3. Okay, my vertices are these guys. So let's see, we ended up at negative 4, 1 and 2, 1. Okay, co-vertices, we're gonna use B. So from my center, I'm gonna go up 2 and down 2 and write those coordinates down. So we've got negative 1. Oh, no wonder, you guys. Okay, I'm just going to start fresh on this one. Let's see if I got a different graph. Yeah, sorry, of course I used a pen. I put my center in the wrong spot. Okay, well, I'm going to use a different color to overlap that. So my center, I did this part right, and I graphed it incorrectly. Negative 2, 1 is right here. So then if I go 3 out, I'm right here. 1, 2, 3. So blue is the correct one. So let's fix these. So I'm at -5 and at 1, 1. Okay, so now for my covertices, I'm going to go up 2 for my center and down 2 for my center. So we got -2, 3 and -2, -1. All right, so now let's connect here. So again, the blue is the one I'm keeping. All right, so the foci, remember we are going to get from the c values. So we've got c squared equals a squared minus b squared. So c squared equals 5, c is square root of 5. Okay, so this time c, I would be adding c along the major axis. So my major axis is along the horizontal. So I'd be adding it to the x coordinate of my center. So my x coordinate of the center is -2. We would add square root of 5. And we would subtract it to get to the right and to the left. And then my y coordinate would stay exactly the same. It's still going to be at 1. So there are 2 foci there. So that is how we're going to write the foci. Domain goes from -5 to 1. Range goes from -1 up to 3. All right, sorry about my extra pen marks there, you guys. Why you should do math in pencil. Okay. Next, we have what looks like it could be an ellipse, but it's not in standard form, right? Ellipses always need to be equal to 1. So here's how we get it to equal 1. Whatever is over here, we divide by itself, right, to equal 1. But whatever I do to one side, I have to do to the other. So I'm dividing this whole thing by 729. So I'm going to try and reduce to get it in standard form here. So if I reduce 9 divided by 729, we can change that to a fraction. So if I hit the math button here, hit math and then fraction, we get 1/81. Or if I had done 729 divided by 9, you're going to get 81. So 9 goes into 721 81 times. So another way I can write this is x plus 9 squared over 81. Okay, plus, and similarly, 81 goes into 729 9 times. So we got y plus 4 over 9 equals 1. Okay, this guy is bigger, so this is my a squared. B squared, so A is equal to 9 and B is equal to 3. Okay, my center here is at -9, -4. Maybe I should learn from this and do this one in pencil. Okay, so -9, these are going by 2's, and then -4. So there's my center. And we're going to go, it's oriented horizontally. My A is under the X, so we're going to go out 9. So we're at -9, so if I go out 9, I'm going to go to -18. And if I go out 9 here, I'm going to end up on the y-axis. Okay? My B is 3, so from here we're going to go up 3 and down 3. And we've got our ellipse. And you know, trying to make these guys round is really the challenge. Okay, so my vertices are at -18, -4, and 0, -4. Covertices are at -9, -1, and -9, -7. Okay, foci, we're going to do c squared equals a squared minus b squared. So let's see, we get c squared equals square root of 72. I can break down 72. Yeah, because 72 is 8 times 9. So we get square root of 9 is 3. Sorry, this isn't good enough. Let's do 3 times. Yeah, this is the same as 36. I can go bigger. 36 times 2, so square root of 36 is 6, so C equals 6 root 2. Okay, so again, we would be going left from the center this amount and right from the center this amount. So that's going to affect our x-coordinate. So we're going to take the center x-coordinate. We'd be adding and subtracting our C value, and the y value would not change. Domain is from -18 to 0 for x values, and our range is from -7 to -1. All right, that is it for the first video on ellipses, you guys. Thanks for watching.